The next thing I want to make sure that we cover is how to do the new infinite geometric series formula with a sigma notation, because even though it's not actually a different formula, it's not even a different process, it may be confusing when you're presented a series in sigma notation because it doesn't seem like it fits the same parameters that questions A through D did. I'll reassure you, it is actually the exact same formula, the exact same process, where you're going to need to identify the A sub 1, the first term, and the multiplier. We're just going to have to extract that information a little bit differently than we normally do, like in letter A, where A sub 1 is just literally the first number in the list, and the multiplier is something we can easily visualize just by looking at the pattern of numbers. In sigma notation, the multiplier is actually in a really familiar place. So this is actually where our experience with sigma notation is going to come in handy. The multiplier in a sigma notation is just the number inside the parentheses that's being raised to the exponent. So in theory, I don't actually have to do much to know that the multiplier in this problem is going to be 3/5, because that's the purpose of this part of the expression. It's always going to function as the multiplier. So weirdly enough, that is the easiest way to extract that info. And I don't need to actually do anything with the sigma, I just need to recognize it as the important location of the multiplier info. Now, the first term might be a little bit weird to think about, but if you think about this sigma is telling you that it's going to start with the first term, and then it's going to keep going term after term after term after term after term, and it's never going to stop. Because remember, the top of sigma tells us where to stop, and you can see that infinity there that tells us, oh, no, this one's not actually going to stop. This one is going to go on and on forever. And I don't need to care about that. I just need to recognize that the first term, the first thing that's going to happen in this series of terms, is whatever would happen when I take 1 and plug it in. So if I don't have a series of terms to look at, like I did in letter A or letter C, where I had a list of numbers and the first term is literally the first thing in the list, I can figure out the first term by just doing a quick little bit of side work. The first term is whatever I would get from this equation, or this expression, if I plugged in 1. So the first term would be 4 times 3/5 to the power of 1 minus 1. So notice how I can just assume that n is 1, because that's what the first term means. The first term is just whatever you get when you plug 1 into your equation. So if I do this, and again, this is just my little side work here, 1 minus 1 is 0. So 4 times 3/5 to the power of 0. Well, anything to the power of 0 is just 1. This is really just 4 times 1, and 4 times 1 is 4. So that leads me to conclude that the first term of this sequence must be 4, or the series must be 4. Now that's not my answer, that's just giving me the necessary info so that I can use my infinite formula, my a sub 1 over 1 minus r formula. So now that I know I have enough info for the formula, I'll use a sub 1 over 1 minus r. A sub 1 now we know is 4 over 1 minus r we know now is 3/5. So just as we were doing before, we can simplify. On the denominator there, 1 minus 3/5 is 2/5. And then we can do a keep change flipped style setup. 4 times the reciprocal of the denominator, which is 5 over 2. You can clean this up however you want. Some people like to multiply 4 times 5 and then 1 times 2. Some people like to cancel. 2 goes into 4 twice, but either way, by the time you multiply this, you should end up getting an answer of 10. So again, the sigma notation still is going to involve using our same formula. It's just getting the information for the formula that differs a little bit. It's not the same as extracting the information from a list of terms like we were up in the top section, but it's the same process. We just have to be flexible to notice that sigma gives us the information in a slightly different way. I'll do one more video with one more example in letter F, but if you feel like you got the hang of it and you can do the sigma problems, you're probably able to finish the page without watching the last video at all. If you want one more example though, tune in to one more video for letter F and see if that helps confirm things.